Hey guys, so what we're going to do in today's lesson is divide some polynomials. Okay, so we've done this before. We've divided polynomials when you could factor stuff, and that always works. But these are going to be ones that you're not able to factor. So you can actually do long division or to divide polynomials, and it's going to help us in the long run solve more polynomial equations that don't look like quadratics, that are more difficult than quadratics. So to get started here, I just want to review, before we get into actual long division stuff, review what to do when you're dividing by a monomial. Okay, so for this first one, we don't have more than one term on the bottom, it's just a monomial. So because of that, you could just split this into 3 different fractions and solve each of those, which we've done before. So this becomes 16x to the 5th over 2x cubed plus 10x cubed over 2x cubed plus 4x squared over 2x cubed. Okay, now each of those we can work with, so this first one becomes 8x squared. The second one is 5, because these just cancel each other out, and the last one is 2 over x, or 2x to the negative 1 power. So that's just a quick review on how to do something like that. Now, if you have a binomial down there, or you could even do it with a trinomial, we're not going to in this lesson, but we'll start with a binomial. If this is the case, you set this up like long division. Okay, so x squared plus 6x minus 10 over x plus 2, not over, but divided by x plus 2. So if you haven't done long division in a long time, like I haven't, basically, remember, we're going to find something to go up top that's going to be multiplied by this to cancel out this the leading term. Right? We're going to keep doing that over and over again until we get a whole answer. Okay? So for the first one, we got to figure out what we're going to multiply x plus 2 by to be able to subtract off the x squared. So we'll multiply by x. Do x times x plus 2, which is x squared plus 2x. Now remember that you're subtracting at this point, so you might want to change the sign like I usually do. The x squared should always go away. Now we've got 6x minus 2x gives us 4x, and you carry down the next term, so the minus 10. Alright, so now we do the same exact process. How are we going to cancel out the 4x? Well, we need to multiply by 4. So 4 times x plus 2 is 4x plus 8. Remember that we're subtracting. Change all your signs. 4x's go away. You're left with negative 18. Now, if you don't remember this part, negative 18 is what the remainder is. Okay, so remainders, all they are is this number over this number. Okay, it's really just a fraction. So we're going to add this to it, minus 18 over x plus 2. And that is the final answer. That's how you divide that polynomial. Let's go to more examples. Okay, so a couple of things to remember about this. I said on the last page, I don't know if you read that, I didn't actually say it on the Y, but you have to have these arranged in order from the biggest term, or the biggest order, biggest power to the smallest one. So we need to rearrange this. And then also, if there's any gaps, okay, so there's a p cubed, but there's not a p squared, you have to write the p squared just with a 0. Okay, so 0p squared, just because that's going to help us kind of stay on track. Okay, so for this one, we've got 3p cubed plus 0p squared, because there's no p squareds, minus 7p plus 6, and we'll divide that all by negative p plus 2. Okay, so we got to figure out how to make negative p cancel out with 3p cubed. So we need to multiply this by negative 3p squared, because negative 3p squared times negative p plus 2 is going to give us positive 3p cubed minus 6p squared. Okay, remember what we're subtracting here, so change these signs. And these cancel out. That's good news for us. 6p squared is what we're left with. And we bring down the minus 7p. Okay, so now we need to multiply this by something. Multiply our negative p plus 2 by something to cancel out with 6p squared. So that's going to be a minus 6p. Negative 6p times negative p is positive 6p squared, and we have minus 12p. Change all the signs because we're subtracting. 5p plus 6 when you carry down the 6. Okay, and the very last one, we're going to subtract off a multiply by negative 5 to give us 5p minus 10. Change your signs, cancel out. 16 for our remainder. So the remainder here is going to be plus 16 over negative p plus 2, or 2 minus p. That's it. Now, number 4 is pretty much the same thing as what we just did in 3, but we'll do it anyway. Same exact process, so we just have to, I just want to make sure we're practicing this gap thing. Alright, so we've got 2a cubed plus 0, a squared plus a minus 3. Luckily it's in order for us already, dividing by a plus 2. So we're going to have to multiply that by 2a squared to get our 2a cubed plus 4a squared here. Now remember that you're subtracting. Okay, so those go away. We've got negative 4a squared plus a when you bring the a down. Multiply this by a negative 4a to get negative 4a squared minus 8a. Remember that those need to be changed, the signs. So we have 9a minus 3. 9a minus 3, we just have to multiply by 9. So 9a plus 18, change your signs, cancel crap out. Negative 21, and our remainder is negative 21 over a plus 2. That's simple, pretty easy. There's one hard one that I want to do, just so you guys see it. This one's a little bit more difficult because if you see on the bottom here, it's x squared, and that's going to really mess crap up for us. But we'll be fine. So for this one, we're going to set it up just like we did for the other ones. Okay, so 4x to the 5th. We've got 0x to the 4th, 0x to the 3rd, 4x squared, minus 2x minus 2. On the outside, you don't have to worry about putting a 0x because it's never going to factor into anything because anything multiplied by 0 is just 0, so you can just leave it the way it is. Okay, but it is going to manipulate. We're going to be kind of jumping all over the place because you do skip a term on the outside here, but I'll show you what it looks like. So first thing we have to do is multiply by something to get rid of that 4x to the 5th. Hopefully you remember your exponent stuff. If not, go back to that chapter and watch those videos again, because you should know that 2x squared times 2x, oh, I need to move that, 2x cubed is going to get us 4x to the 5th. All right, 2x cubed times 2x squared is 4x to the 5th because you add exponents when you multiply monomials. And we're going to, and 1 times 2x cubed is just 2x cubed. Okay, so we skip kind of right over the x to the 4th. So we have to change our signs because we're subtracting. Those cancel out. Good news. Minus 2x cubed. Bring down our x squared. 4x squared. And we need to multiply this now by negative x. Because you multiply by negative x, and we'll get negative 2x cubed minus x. Now notice here that the minus x, I should probably move that for us as well. This minus x isn't going to subtract with the 4x squared. Okay, so that's where we kind of get a little messed up. Now remember, we're subtracting here, so we need to change those signs. Those cancel out. The 4x squared just stays, because it's basically minus 0x squared, right? And we're going to bring down that negative 2x, right? Bring down the negative 2x, it's going to combine with our positive x to make a negative x. Okay? Now, the next thing we have to do here is just do the next step. Okay, so we're going to multiply by 2 to get 4x squared plus 2. Okay? Remember, we're subtracting. Those go away. Bring down the negative x. Bringing down the negative 2. The negative 2 combines with the other negative 2 to make a negative 4. So our remainder is actually negative x minus 4. Okay, so what I'm going to do is I'm just going to subtract x plus 4 over 2x squared plus 1. Right? The reason why I can do that is because if you pull this negative out, it's going to become an x plus 4. And I know that one's difficult, but that would be the hardest type problem that you'd have to do for something like this. So as long as you can do the original stuff, make sure you can do those first, and then we'll get to these harder problems. That's it.